Hello. Yeah, so this is the second part of the video for the code review. So here I will going to talk about the top file, which is this top file is basically consisting two main components, two main files. If we see here in algorithm, right? So this is the algorithm. So one part is the key generator here, and the second part is the algorithm itself here. So these are the two main parts of algorithm, and this top file has two different component instantiated. Here we can see component key gen. This is key generator. So that is this file here on left hand side. And the second one is algo that is algorithm. In that file I have code for the algorithm, right? So but in this video I will going to talk about this part, the key generator. So before we talk about key generator, let's look at this file. So this top file basically defines like which it helps us to create the interconnection between the generator and the algorithm, this algorithm and the generator, right? And for interconnection we have all these signals, different signals here, and also this is a clock. So there are three main things in algorithm. One, clock. Second, the reset bit, right? This is clock. And the third one is count. So all these things we will going to see in the last video when I will run the simulation. But like and these three, clock, reset and count, those are the three main things that drives the encryption algorithm. Depending on the value of clock, reset signal and count, we will be driving the encryption algorithm. And then here we have port map for key generator. So this basically indicates that which signal, which local signal. On right hand side always we have signals. This key signal, key gen is one of the signal, this clock is signal, and on left hand side all these are the ports of key gen, that is this file here, right? So which signal, this port map is nothing but it is indicating which signal is connected to which port. And also for this algo, this is a port map, right? So let's see this key gen. Okay. Yeah, so here entity key gen, we have different input and output ports. This is key in. I need to hop back and forth like between top and key gen so that we can understand it better. Key in is basically the input key. Key out is the output key that is generated. CLK is the clock that is coming from top, right? Reset is again the signal that is coming from top. Count is the integer value that is coming from top, and those are as I said, this is port mapping. So this is how the key signal here is connected to key in of key gen. So key signal, if we see this key signal, standard logic vector 127 down to 0, that means it has 128 bits, and the value of those 128 bits is um, assigned like this through hexadecimal. So we have total 32 hexadecimal value here, 0000102 up to 0f. So that is total 128 bits that is being passed here, right? And in this keygen, this is architecture. Again, we have some signals, local signal that is being used in key generator. Then this is user defined signal here, this one. This basically says word array, that is a type, is array 3 down to 0, that means 3 to 0, that is total 4 of standard logic vector. Each will be having 31 down to 0, that means 32 bits, right? And the signals are keyword and new keyword. Those are of type word array, which we have defined here, word array, this one, right? Then I have component SBox that we saw in last video, SBox 4, right? 31 down to 0, and this is the beginning of architecture of key generator. So here I have current key and key out. Both of them are signals. So, and also these are process, one process, then this is another process, this one. We will see about each process. So this process basically says that whenever the reset bit is 1, assign the current key value 0, all zeros to current key value. Or if the clock event happen and clock equal to 1, right, then if count is greater than 0, then current key, which is a local variable, it will get the value of new key. Otherwise, for all other counts, the current key will be the value of key in. Key in is the value that is being passed from top here, right? Then I have divided the current key in 4 parts, 4 words, word 0, 1, 2 and 3. So each word would be having 32 bits. Then as per the algorithm, we can see here So first thing is rotate circular left by 8 bits. So this is what it's doing, left shifted, right? So that is assigning first 23 to 0 bit and then appending the last 8 bit here, 31 down to 24. So that is being concatenated, and the first byte is concatenated at the end. So that will create like this. If we have okay, yeah, K12, 13, 14, 15. Then after left shifting we will be having K13, 14, 15 and K12 at the end. That's what it's doing, this one. Then this is a port map. So left shifted signal, whatever we have after left shifting, that we are passing to the SBox 4 that we saw in last video as an input for the SBox substitution, and the output will be assigned to SBox signal, right? This one, that is output from 4 SBox. Next thing is XORing the SBox signal with round constant. Round constant, again, this is a part of algorithm, and each round has different round constant value, and to change that round constant value I have this process here. This process defining what would be the round constant value for each round. We can see here for count 0 greater than count greater than 0, round constant would be start at 0, 1. Then on every clock cycle it would change to different round constant value, 0, 1 to 0, 2, from 0, 2 to 0, 4 and up to 36. Again, if we have 36 and on the next clock pulse it will go to 0, 1 again here, back here. Yeah, so this will continue like from top to bottom and then again to the top, right? And so that is a process for round constant, and that round constant is being used here, XORing with the first bit of the output whatever we have get here, right? Then then the output will be MSB, and that MSB is then appended here with SBox signal rest of 23 down to 0. So that is how we have G function. So this thing here is we can map here this G, and then we have this to generate this W4, 5, 6, 7. We have XOR operations. So to generate W4 we are XORing the G, right, this one, and word 0 of the current key, that is here. So new key word 0, there is nothing but W4 here. W4 is the keyword 0, the previous key, XOR G function, right? Same way, word 2 is keyword 1 of previous key XORed with keyword 0 of previous key XORed with G function value. and so on. So we'll be having new key here, right, after all this XOR operation, and that new key will save like this 32-bit ending with this 32-bit, so 32 fours are 128-bit. So that is how we have new 128-bit key. So this is a key generator. In the next video, I'm going to talk about the algorithm round.